Hello, I am Baily. I am a software engineer at ACV Auctions, and we're going to talk about how to get your code into a production-like environment. We're not going to actually deploy to a production environment because there's several other components that we're going to talk about later that you would need to add. But it's a start. So who am I? I'm a software engineer at ACV Auctions. If you haven't heard of them, they're a pretty big startup in Buffalo. I'm a former CS student at UB. So shout out to UB. I'm a Buffalo native and I like hot tubs and I like cheap beer. So what is this presentation? Let's say you have a site and an API, but nowhere to put it. You're running on Localhost and you want to have something that you can demo to users, but you don't want to pay for something like Netlify or Heroku. You want to do it on your own. And I just want to emphasize that what we're going to do today is not only for neckbeards and senior engineers. You can do this if you're a student or if you're a fresh grad, or if you're just getting into operations and how to actually deploy code beyond just what you have on your local machine. It's so easy, a C-level can do it. I don't know, I coined that term, and I just want to emphasize that most of this stuff, with a little bit of effort, you can go really far. So what is our pipeline of events? So we're going to go through an example repo that I created. We're going to go through Docker, Make, and what are our steps for our two example services to actually get them somewhere. And then we're going to talk about ECR, AWS. How do you create a domain? How do you make a hosted zone, a cert? And then how do we actually deploy that into a environment? So we're going to use Kubernetes using kops because we don't want to pay 10 cents per hour using AWS's managed Kubernetes service, EKS, because that's the price of two T2 mediums, which is kind of ridiculous. And then we're also going to go through how do you wrap that in a Helm chart, and then also how do you make a pipeline to do all of that automatically for you once you actually are writing code on your own. Cool. We'll talk about that later. So I actually just made a PR updating this little presentation site. I'm going to squash and merge it, and then that's going to deploy back out. And then hopefully in a couple of minutes, let me send this presentation to y'all so you can see it. Chat. So that's the presentation. And then this is also the example repo that I kind of set up that we can kind of walk through, and it's public, so you can reference it at your leisure later on if you were like, oh, what did Baily do that one time when he was making that presentation? And then hopefully once CI actually finishes on this website will get updated, and it'll have a link in this example repo part right here. And before I continue, can you guys actually see my screen? I'm not just, talking with a black screen. Sweet, awesome, cool. So let's take a look at what we're dealing with first. So we have this example repo with a lot of words. We're not going to go through the words because you can read on your own. But we have a couple of examples. And I guess I just want to preface this with what is this BFLO box? I think to make it a little bit more interesting, I wanted to have a little theme around it. So let's say you're a new billion-dollar startup idea and you have everything running on localhost and your pitch is Buffalo Box. What is Buffalo Box? It's a next generation subscription service that's Buffalo themed. So it's Buffalo themed swag, and it's also food. So, you have food deliveries. Maybe you get Paula's Donuts and maybe a Duff's Wing shipped in a box to you during lunchtime. Regardless, it's a website, it's an API, and we want to get it in an environment that other people can view besides yourself on localhost. So let's look at our examples. So we have an API, we have our website, we have our presentation site, which I kind of just bootstrapped last night. And then we have a Helm chart. We'll talk about Helm later and what that means. Let's first look at our API. So this is just a basic Golang HTTP API. Don't really worry about any of the specifics. If you haven't used Go, that doesn't really matter. The only thing that matters, and I'm going to show VS Code here. Can you guys see my VS Code as well? I don't want to, sometimes it only shows like one window. Sweet, awesome, cool. All right, so we have this example API. It's just a simple API that has a health point. So what we're going to do, let's just look at the README to make sure that we're all on the same page. If we run make build, it's going to build our image. And as it's building it, let's talk about Docker. What is Docker if you haven't used it ever before? So if we wanted to, we could install Go locally and run it. We could do go run command main.go and run our service just like that, willy-nilly. But what if we want to run this somewhere else? And I kind of focus on the fact that Docker is meant so you can run your environment anywhere, agnostic of where it's actually running. I don't know, I think I'm funny. You may not, but that's fine. After all, we need to easily run our code base from anywhere, and I mean anywhere, on Linux, Ubuntu, CentOS, macOS, your grandmother's Windows XP laptop. So that's kind of important. So this is an example Docker file, and it has a couple of, I guess, slightly more advanced concepts that we're not going to touch upon right now, such as like building from scratch. But I think the core components, and I'm going to talk a little bit quicker because we kind of have to go through this whole pipeline, but feel free to look at the examples later. And I have this nice docs, and we're going to talk about Docker in this docs that goes through everything that we're doing. What are some of these commands from, work, dir, copy? What does that mean? You can look at it later. That's perfectly fine. So this is our basic Docker file. We have a generic Golang image, a base image that we're pulling from Docker Hub that was made by some fancy person that did it on their own. We're going to add in our local files. We're going to run some updates to make sure that we have Git. We're going to make our working directory, and then we're going to actually install and create our Go binary that actually runs our application. So when we do something like make run, we have an actual application running on localhost at 8080. So if I curl localhost 8080 at health, boom, status healthy, sweet, that's awesome. Let's pretend that that's a full-fledged API that handles everything Buffalo Box related, but we only having it running on localhost. That really sucks. So what are we going to do now? What do we do from here? There's a container image repository that we want to store all of this in. You've probably heard of Docker Hub. If you haven't, it's basically NPM or just a basic app store for Docker images. And we're going to make our own private one in AWS. We're going to do that eventually. And then we're also going to talk about Amazon. And we're also going to talk about how do we actually get things up and deployed. Cool. So we have this example API running. If I do make run, it runs a local API at localhost 8080. Sweet, that's awesome. So where do we go from there? We are going to push it to this container image registry called ECR. If we go to AWS, and I have some docs on how to create an AWS account if you don't have one. AWS is what we're using. You can use Google Cloud. You can use literally anything that you want. I like using AWS because that's what I'm used to. I started using GKE a couple of months ago, but found it kind of painful to actually set up environments in Kubernetes, let alone just their whole networking layer. I just think it's a little bit more than I want to have to deal with. So there's a tool called ECR, Elastic Container Registry. And what you would do is you would go here, you would create a registry, you would call it whatever you want. Once you create it, you have this fancy string that has your registry name. I've already created it, sorry. And this is our string. This is our actual link to post stuff to Buffalo Box API. So what I would do is I would make build, I would tag it, I would do Docker tag, and then Buffalo Box API latest, and I would tag it as this ECR link, and then I would also give it a tag. I would tag that, and then I would literally just Docker push, but we use make because make is easier. And all I'm going to do is I'm going to do make push. So this is just logs me in, tags that image that I previously built, and pushes it on up. I can do that right now. Make push, cool. Bam. I have really slow internet and I already have CI/CD set up, so I'm not gonna let this finish because it might be 5 to 10 minutes. Maybe not. It's this one right here is probably gonna take way too long. So cool, we've built an image that's running this API on this fancy port, and we're gonna push it up to ECR. That's really cool. What next? So let's talk about Kubernetes and DNS, because it's kind of important. First, let's talk about DNS, because we're going to have some DNS records created to create our Kubernetes cluster. So let's look at this example here. I created this doc. I'm not going to read this for you. You can read it on your own if you would like. But the core components is creating a domain on Route 53. You can create a domain on literally any registrar that you want. I prefer Route 53 because it's easier to connect everything else up to. What we're going to do is we're going to buy a domain, we're going to create a hosted zone, and then we're going to create a TLS cert using Cert Manager. So you'd go over into this fancy tool called Route 53. Is it register domains? And you could register a domain. I already purchased this one on September 26th, so somewhat recently, so I could actually like get this presentation website set up. But you would literally just go here, you would search stuff. So I don't know, Baily's demo right now. Let's see if we have I'm assuming it's available, I'd hope so. You'd add to cart, you'd continue. You'd go through all of this, make sure that you have this enabled unless you want people going on Who Is and seeing your address. I personally don't. And you'd register that domain. And magically, Route 53 is automatically going to create a hosted zone for you, which is really cool. A hosted zone, think of it as just an encapsulation of domains. So you could have subdomains within that hosted zone, kind of like, you know, API.buffalobox, www.buffalobox, presentation.buffalobox, and you would put all of that inside of here. And you can also reference other hosted zones inside of each other if you want to have like further encapsulation, which is really nice. So this probably looks pretty foreign if you're not an actual, you know, infra engineer or operations person. So we're not going to worry about this too much, but what we want to focus on is the fact that we have the name of our domain, we have this fancy type, and where is it going? We're not going to worry about name servers, and we're not going to worry about anything other than CNAMEs. CNAMEs are simply aliases to other domain names. You could have an A record, which goes directly to an IP address, or a CNAME. Right now, we're going to do CNAMEs. So we could theoretically link, you know, this example API.buffalobox and CNAME it to another load balancer. What's a load balancer? We'll talk about that later. Cool. So theoretically, you would have created a domain name using Route 53. That would create a hosted zone for you. And now we can just shove stuff in here, which is really cool. What next? So now that we have our example image built and pushed into ECR, what are we going to do next? So we're going to create a Kubernetes cluster. And this is where it gets a little bit more coked out. You could run in something like Docker Compose locally or in an EC2 instance and just port forward that. But what if we wanted a more distributed environment that has more fault tolerance? You can bump up replicas easily and you can deploy things easily. That's why we're using Kubernetes. And I'm not going to say that Kubernetes is as simple for a C-level to do within like 5 minutes. It's not. There's a lot of nuances and a lot of custom resources that you have to kind of understand in order to get this working. But we're gonna kind of just hand wave through it, and then you can look at these docs later, which will kind of reference and point you in the right direction. All right, well then how are we gonna create our Kubernetes cluster? We're gonna use Kops. It's a fancy tool created by, I believe it's created by the Kubernetes team. That just helps you create and bootstrap a cluster. I kind of mentioned this before. We could use EKS, which literally is a button in Kubernetes, but they literally charge 10 cents an hour to just operate the cluster. That's not even including the master node, just to operate it. That's $70 a month that I don't want to spend. Now I've already created this cluster, but I literally followed these steps that I have right here. You would install Kops if you're if you have Mac, I would use brew, or you could just curl the binary directly and install it on your path. The only nuance here is you have to create a hosted zone for your cluster and then create an S3 bucket that Kops can store all of the cluster configurations inside. So if we look here, I created an S3 bucket called clusters.dev.buffalobox.com. I export it so the Kops binary understands where that store is. And then I create my cluster. I called it useast1.buffalobox.com. You can call it literally whatever you want. And then from there, the default node types, I think, was a T2 medium or a T3 medium. I didn't want to spend that much money, so I bumped it down to a T3 small. You would do something like Kops edit, and then you would edit your cluster, and then it would open up a YAML file in your editor or inside your terminal. And then you could navigate and find that cluster name and change it if you'd like. And then from there, you would run this literal command, and it would create your cluster. And this is very hand wavy, and I'm completely aware of that. But if you just want to get something up and running and then learn about it later, this is what you got to do. I figured it would be better to kind of hand wave through this whole process, and then we can answer some questions. And if you wanted to actually learn in more detail, how does COPS work? How does Kubernetes work? You can do that on your own time. And then after that, what we would do is we just validate this cluster. I think it took like 5 to 6 minutes for me. So, I grabbed a coffee, played some music, whatever. And now we have a Kubernetes cluster. That's awesome. If we look at my terminal here, this terminal, I'm using Z shell. You can use whatever you want. You can use fish, bash, whatever. I have a couple of fancy UI elements here. One of them shows me the cluster that I'm currently in. And if I do something like kget nodes, I can see all of the nodes. I've got 3 nodes, 1 master and two little worker nodes, which is great. And I can, see how many namespaces that I have. And, I have a Buffalo box namespace. Sweet, that's where we're gonna put our stuff in. But what's a namespace? What is a node? What even is this? So let's talk about that next. Are there any questions thus far? I feel like we're kind of at, a good stopping point if anybody has any questions right now. Cool. So we have kubectl and Helm. So let's look back a little bit and see where we've gotten so far. We have this local API that's running on localhost 8080 that just has a health endpoint. It's really cool. So we built it using Docker and we pushed it up to ECR. That's really cool. What do we do with that? It's just bake in an ECR doing absolutely nothing. We know we made a Kubernetes cluster. We don't really know what that is, but we know we have this fancy cluster. How do we actually take the ECRs and how do we put it in the Kubernetes? That's what we're going to talk about right now. So I have a kind of baked version of my explanation of Kubernetes. There are billions of articles on Medium with hipsters and neckbeards explaining Kubernetes from the kernel level to the how do you get it running. But the important part, if I were to explain it to a newbie in a 5-sentence explanation, you have these buckets. These buckets are your namespaces. These namespaces hold custom resources. What are these resources? You have these abstract constructs in Kubernetes that are deployments, daemon sets, cron jobs that kind of encapsulate what you'd even want to do in this environment. Well, you want to deploy something. That's a deployment. You want a cron job that runs at a specific cron. If you don't know what a cron job is, that just runs something at a specific time, albeit every minute, every 5 minutes, Monday at 9:30. And there's a bunch of other resources that have slightly more nuances on top of that. For example, you have stateful sets and you have daemon sets. But let's just stick to a deployment. We have an API that is stateless. It doesn't have any state. If we wanted to add an API, if we wanted to add a database, that wouldn't really be state that's embedded on, like a volume. That's just something that's an endpoint that we call and connect to later. So we have a stateless application that we want to run. We have a deployment that we want to create. And that's, I'm telling you that we are going to create a deployment in Kubernetes. So how do we do that? We're going to use Helm. We're not going to create bare bones Kubernetes resources. Some people would say, let's actually learn about the resources first, and then we'll talk about Helm. But that can get a little bit confusing, and there's a lot of directions that you can go in. And obviously, all of this at once is a lot to take in. So we're just going to go right into Helm. What is Helm? Think of it as the NPM of Kubernetes configurations. It allows you to easily bootstrap and create a whole application with one command. And that's very hand-wavy. There's a lot of stuff that's going down in that Helm route, what's actually happening when you run Helm install. And we'll talk about that. I'll show you the chart that I built. That's an example that we're actually deploying right now. So we have this construct of Kubernetes that has these namespaces, which is a pretty easy concept. You have this thing that you want to put something in. You can have a namespace for every application that you have. You could have a namespace for a team. You could do whatever you want, but you have this namespace that you put stuff in. Cool. And then we have these resources, deployments, services that do stuff that run our container. Okay. And then we know that we can install those kind of resources majestically using this tool called Helm. So let's dive a little bit into what Helm is. And then which in turn is going to help us conceptualize what Kubernetes is. So we have our basic README right here. Actually, it might be easier if we look just directly in the browser. So let's look at our example. We're going to go inside example Helm. That's going to hold our Helm chart, which in turn is going to hold our Kubernetes stuff that we want to deploy in our cluster. And this is just a generic README that's kind of copy pasted from Helm stable, which is kind of the app store for all public Helm charts. If you just GitHub Helm chart, there's this whole repo. Well, they're all technically legacy now since Helm 3, but all of these repos of tons of services that you could want to deploy with a single command, from Prometheus to free versions of S3 to Kafka to anything that you can think of, you can install easily with Helm. So you don't have to manually create those Kubernetes resources. So we have this chart. We can install this chart literally by just doing Helm install, but we also have some configurations. We've got, metadata. We've got what is our image, what is the port that it's running on, and what is our load balancer SSL cert. So by running this, it's going to install a bunch of fancy resources. What are those resources? So let's look at the actual file structure for this repo. We've got a chart.yaml, which is just basic metadata for our Helm chart. What is the chart name when we install it? What is an example description? Cool, that's fun. We've got a README, whatever. We've got this values file. What is this? So this is our template values. So Helm is a templating engine that simply bundles and templates Kubernetes resources. So it's not actually doing anything other than taking these values and shoving them in other files. That's it. And then on top of that, you can manage these constructs, these Helm objects in the cluster. That's another bonus that Helm actually provides us. So we have this generic values file. The hell is this? Let's just look at what is actually inside of here. So we've got our provider, what's the region, what's our cluster name. This is all just labels that we can use to kind of filter our application once we deploy it. And then we have our main container. It's called Buffalo Box API. It has a name. It has a link to ECR. Change this. I specifically have this as change this because I don't believe in latest as a tag. I think it's an anti-pattern. So we're going to override this when we actually do the Helm install. Then we have some resources. We have a port that it's running on 8080, which I've mentioned like 5 times now. And then we have this load balancer cert. What is that? We'll talk about that later. So that is our values file. This is the stuff that we're actually going to manually put values in or override them based off of this table here. And then we have templates. These are the things that are actually getting overridden when we actually install our Helm chart. So what are these? We'll talk about helpers later. That's not really easy to conceptualize at first. So I talked about before that we're going to have a deployment. This is it. This is our deployment. Wow. Really cool, right, guys? This is really interesting. It's just a bunch of templates. For example, in a nutshell, shout out to Magnet for letting me do this. We have our values and we have our template. So think about this. In braces, in double braces, .values, .meta, .name. What does that mean? It literally maps meta name and shoves this value Buffalo Box API into our app right here. That's it. Include labels. Well, what does that include mean? It's not .values, it's a little bit different. So we have this helpers template, and it's simply going to take this whole string or this whole block of objects, and it's going to slap it as the value of labels, and it's going to indent it 8 spaces on the next line. So this is our deployment resource. There's a lot of configurations that you can specify, and we're not really going to talk about them all because we could probably spend a whole hour talking about just deployment objects. So let's just look at the important meat and potatoes of this resource. We have our containers. We have one container. Since this is YAML, this is a single element in our list. We have a name. We have the image. So if we look back at our values file, nope. Values container, Buffalo Box API image registry, repository, sorry. It's going to map to this and then whatever this tag is. So theoretically, if I installed this right now, it would be this semicolon change this. Image pull policy, every time the container starts, it's going to pull a brand new image. Resources, it's just going to take this block right here and shove it in there. What does this mean? This is our CPU and memory limits and requests for our container. I'm not going to go into too much depth on what that means, other than that is literally how many resources are we going to give our example pod. Then we have our ports. What is this pod going to be exposing? 8080. And then we have some probes. Simply put, a probe is going to make sure that your application actually runs at the endpoint specified. So if it doesn't successfully expose 8080 health, it's going to freak out, it's going to crash, it's not going to run. That's pretty helpful, because otherwise you would have this weird black box application that's not running the way it should. Why is it not running the way it should? Who knows? This way it fails fast. And that's kind of what we want. And then we have this fancy volume mount. I forgot to mention this, I apologize. So if we go back here and we go to our example API, I mentioned in the README that we have a configuration that's required. It's just a config YAML that specifies the name and the port, so it can be a little bit more dynamic. All I'm doing is storing this file as a secret in Kubernetes, and I'm referencing it here. So I have this volume that I'm going to create from a secret that I called buffalobox.api, and I'm just going to shove it in the secrets directory. Cool. So let's backtrack a little bit. We created our image. We pushed it in ECR. We created a Kubernetes cluster. And now we have this construct called Helm. Helm templates all of our Kubernetes resources based off of a values file. And then from there, we magically install it. Let's actually install this and see how that works. So let's go to the terminal here. We have our Kubernetes cluster, and I'm using shorthand. You can do kubectl, git namespaces, boring, or just kget ns. And we can get all of our resources in the Buffalo box namespace. So this is going to get everything in that box of stuff that we call a namespace, and we specifically called it Buffalo box. So if we look here, we have a deployment, our pod, and a service. Cool. Let's try and install it. So if we go to example Helm, I need to figure out what version this is running, otherwise it's going to freak out. So all I'm doing is just editing this pod just so I can take a look at the image version. I could also just do something like, kget pod buffalo box API -o YAML, and then just grep for the image. Typing. So it's this. So if we look at my example repo, let's go to Helm, and let's Helm install this. So I have this in my bash history. I'm not going to type it out. I'm sorry, I'm lazy. But we're going to simply upgrade -- install, which is simply the same thing as install, except we can consistently upgrade on top of that. You only install something once. You only live once. You only install it once, but you can upgrade it and -- install it multiple times. Meaning, if this chart doesn't exist at all, you could technically run this, and if it tries to upgrade something that doesn't exist, it'll just install it for you. That's really cool. So I have a local chart in this directory above right here. I'm going to Helm upgrade the name of the chart, Buffalo Box API. The chart itself is in our current directory. I'm going to install it in the Buffalo Box namespace. And I would previously, I had a development YAML file that I was going to override, but I kind of removed it. So we're not going to talk about that. And then I'm going to override the values files tag. So remember before how I mentioned that we have this change this here and how that's bad and how latest is bad? I'm simply going to override it using Helm's syntax, which is simply -- set and then the literal path in the values file that I want to override. So containers.buffaloboxapi.image.tag. Containers, Buffalobox API, image, tag. And I'm going to set that to an ECR tag that we pushed up. And just to kind of clarify what this is all doing, if I add the flag debug and dry run, it's going to spit out all of the YAML configurations that Helm automatically generates for us, which is really cool. All right, let's take a look. So we've got deployed true, didn't actually do it because we did debug dry run. We've got some of the computed values. And then we actually have our resources. So we've got a service. What's that service mean? We'll talk about that in a couple of minutes. And then we have the deployment that I was kind of going through before. Notice how it's literally taking all of the information here and shoving it in here. You know, name Buffalo Box API. It has the correct image and tag. It has the proper resources, the proper port. And this is all correct. This is awesome. This is great. And this is what we want to install. We're not going to install right now because we can have our CI/CD pipeline do it for us. But I could theoretically just press enter right now and it would be fine. But we've got more things to do and there's more daylight. So let's step back a little bit. What have we done thus far? Let's look at our presentation. We went through the example repo. We talked briefly on Docker make. We didn't talk about the steps to deploy. We'll talk about that later when we talk about CI/CD. We pushed our image to ECR. We kind of navigated AWS. We created a domain, theoretically. I already made it before this. It already made a hosted zone in Route 53 when we made that. We still have an SSL cert to create. We created our Kubernetes cluster and talked about the Helm chart. And then we also, no, that's it. Cool. So let's talk and pivot a little bit towards the web stuff. So like I said before, we're Buffalo Box and we have an example API and we also have a website because that's what our users are going to interface with. They're not going to just, you know, start curling and making requests for our API if they want to have, you know, a new box shipped to their house. So let's look at this example React app that I bootstrapped using Create React App. So let's look at the README briefly. So this is a simple React app. If you haven't heard of React, I'm not going to talk about it. It is a simple framework that allows you to use JavaScript and make websites, yada, yada, yada. If you've probably heard of Angular, there's also Web.js. Depends if you're a boomer or if you're, you know, a zoomer, depends what framework you use, but that's just me. So we've got a couple of make commands to kind of build this. We're using Docker, kind of like the API. We can build it, we can run it, we can lint it, we can test it. That's fun. Let's build it and let's run it live and see what it actually looks like. Hopefully this doesn't take too long. Cool. Docker caching. Thank you. Want to run it? I built that image. I didn't build Buffalo Box latest. Whoops. Oh, I know what I'm doing wrong. Okay, we're not going to worry about that. I'm not going to debug this right now. I'm just going to do yarn start. Maybe I'm not. I'm not in the right directory. No, I am. Woof, woof, I didn't install my packages. Rest in peace. Okay, that should take a couple of minutes, hopefully not too long. While we wait for that to build, are there any questions? All right, no questions. Cool, let's build it. Sweet, sweet, cool. It's gonna build our React app and run it in a dev server on localhost 3000 and it's erroring out. Oh no, that's so sad. Why is it erroring out? I know why. So we have a end.development and it's looking for localhost at port 8080 and we're not actually running our API. So let's just quickly go back to API and make run. Nice. Let's give it a refresh. Boom, healthy, sweet, nice. So this is our example Buffalo Box website. It's really simple. the thing that we want to focus on is the fact that this healthy is coming directly from our API to prove that they can both talk to each other. Not token, health, nice. So that status healthy is coming directly from the API and we're printing it out right there. That's great. Just to prove it, let's look at our simple application. If you don't know React code, that's perfectly fine. All we're simply doing is making a GET request to /health, and we're going to display it. Nice, cool. So we've got an example website running locally. That's awesome, but we kind of want it to go a little bit further. So what are we going to do? So we're going to use a script that React provides us in Create React App that bundles and builds our static assets. The actual assets that we are going to put somewhere on the internet so people can actually access it, an actual HTML element. So we would do something like, let's look at our makefile and see what we have available to us. And I'm kind of going through this as if I have no idea what this repo is. Obviously I made it and I know how to do this. What we would do is we would simply, we could build, run, lint, and test it. That's cool. But what if instead we wanted to build the actual static assets? So there should be a directory called, or a make directive called build static assets, which is simply going to run yarn build. It's also going to take in our environment file that has a link to our API, which that shouldn't be localhost for end of production. I'm probably not on the right. There we go. So we could theoretically make build static assets. Wow, cool, fun. What is that going to do? It's just simply going to use React, bundle all of our assets, and shove it in a directory. That directory is going to contain our entry point, should be in public right build right here. It's not done yet. There we go. This is our main index HTML that users would actually view. That's going to kind of load and bundle and use all of that React code that we wrote. The point is we want to put this somewhere so people can actually view it. So what are we going to do? We're going to use S3, which is a simple, think of it kind of like Google Drive, but for, I don't know, the cloud. It's just a simple way to store files remotely in an actual bucket. Bucket being a construct for an actual like group of entities. So I already created our example S3 bucket. All you would simply do is press create bucket, give it a name. We'll just do, give it a name. Next, you would not block all public access because this is a public website. So that would be kind of the important part. And then similarly, since this is not public, we also want to add a bucket policy that allows anonymous read access. If you don't want people actually viewing this, or you want specific IAM policies, you can obviously do that based on your own prerogative. So we have this example S3 bucket that has all of the contents that we have locally inside of this build directory. We could theoretically push it up using build or make push static assets, which is simply going to copy everything in build and push it up to our S3 URL, which is buffalobox.com. That's really cool. Then what? So we've got all of these files in this bucket, and theoretically we have this index HTML. This is what we're actually going to view. What we could do, we could go into properties, go to static website hosting, use this bucket to host a website. What's our index? Index.html. We're not going to worry about the error document for right now. We'll save it, boom. We could theoretically go right here and boom, we've got this website running. That's awesome, that's cool. That's an extremely disgusting URL. But we could do that, we could. We're not, sorry. We're not gonna use S3. We're gonna do something a little bit fancier. We're gonna use Cloudfront. So we're going to actually create a CDN distribution, which is just a distribution in a content delivery network that simply has our website on remote edge locations. It makes it really quick for end users to actually pull and view our website. And we're going to do that with a couple of button clicks. It's really simple to make a distribution in Cloudfront, not CloudFormation, Cloudfront. So I already created the distribution. So this is kind of like a half-baked live demo. I just didn't want to have the risk that these distributions take too long, and creating a COPS cluster can take up to 10 minutes. So I didn't want to derail the actual presentation because this does take a little bit of time, and it is kind of a pain in the ass, pardon the French. So we have this example distribution here that is simply buffalobox.com. Let's go through what I would have done if I actually made it right here. So I would go into Cloudfront, I would create a distribution. It's a website, so we're gonna click web. And our origin domain name, what does that mean? They have these helpful, information blocks right here, but TLDR, this is our S3 bucket. So we would select buffalobox.com. Origin path, we don't care about. Why? Figure it out. This is just a guided tour. Redirect HTTP to HTTPS. Yes, we want to do that. What are some other important configurations we want to set? Most of this is not what we care about right now. Edge locations. I'm personally only going to use US, Canada, and Europe because I don't want to have to pay more. Alternate domain names. So how are we actually going to access this? www.buffalobox.com. You could also do buffalobox.com, but just for this example, we'll use www. We would add that CNAME, and then we would attach a custom SSL cert. Oh wait, I didn't go through that. Let's quickly do that because it's really simple. An SSL cert, what is it? It's the thing that gives you that fancy lock. Or if you don't have that fancy lock, it gives you an extremely ugly message that says that your traffic connection is unencrypted and you might be at risk. So let's go to Cert Manager, create an SSL cert. It's really simple. I already have one. I don't know what it's. Why is it not showing me my? It quickly shows it and then it redirects me to dash first run. Why is it doing that? Huh. All right, I guess we're going to create a dummy cert right now. So we would request a public certificate. We would give a couple of domain names. And then from there, it will create our SSL cert. Let's, I guess, go through this workflow because for some reason it's not showing me my previously created ones. www.buffalobox.com. DNS validation, cool. Review, confirm and request, awesome. Continue. Yeah, AWS is, oh, I'm in the wrong region. That's really silly. My bad, guys. There we go. Whoop. All right, so we're going to quickly rush through this. So we have our example cert right here. I went through that workflow before. You would simply just create a CNAME for an entry that it gives you to validate. And we have this example SSL cert. We have an ARN that we can actually tie things to it. And we would simply, in CloudFront, select our SSL cert, which comes up in this dropdown. From there, that's it. We would press create distribution. It would load for 5 minutes, and then it would create an actual distribution that goes to the specific domain name. So if we go to this directly, it's our website. Cool, that's awesome. Similarly, we can take this domain name and we can CNAME it in Route 53 to be whatever we want. So if we go into Route 53, we would go to our hosted zone that we were talking about before, and we would create a CNAME for www.buffalobox.com. Right there, CNAME, simple, and it goes to that CloudFront distribution. Awesome, sweet. Right, so we theoretically built and pushed static assets to S3. We exposed those assets via CloudFront, so it's in a CDN. We also have an API that's running in a Kubernetes environment thanks to Helm. What is there next? Thankfully, we can probably get through this whole thing in the next 5 minutes. So let's talk about CI/CD. Actually, before we do that, let's quickly touch upon how do we actually expose this API. So we talked before about having a deployment. How are we going to expose it? So if we go to our Helm chart here, we go to example, we go to Helm. templates, and then service. There is a type load balancer. So we're using an elastic load balancer. We should probably be using an ALB, but this is simply what's automatically created by Kubernetes for us, given our annotations. So what are we doing? We're simply going to take the port based off of any pods that match that app name, which if we go to deployment, split them up like this, we notice that our deployment has the labels matching meta.name based off of our helpers template. So we have app here inside of our labels. And it's simply going to port forward anything based off of this target port. Okay, and that's kind of weird. What does that actually mean? So if we actually look at if we look at the service inside of our Buffalo box namespace and we just apply it, we just full send it. We create this resource. It's going to create a load balancer called Buffalo Box API that has this external IP. Interesting. External IP, and it's exposing our service. What do we do there? What if we copied this, went into Route 53, and created a CNAME for api.buffalobox.com that went directly to our load balancer? What if we did that? Would we get something like this? We would. So we used Helm to build an image, push it in ECR, and then in Kubernetes, we have a deployment that's running one pod that's running our application, and it's port forwarding 8080 to our load balancer, specifically 443. Okay, that's cool. And we CNAMEd it to api.buffalobox.com in Route 53 after having created a domain name in Route 53, which in turn created a hosted zone for us. Wow, yeah, it's a lot of dominoes. Which leaves us to the last step. How do we do all of this when we push code? And that leads us to CI/CD, which is a buzzword right now, which is also Kubernetes, which is also a buzzword. All of this is buzzwords right now. But let's specifically look at how do we actually get this working in GitHub with GitHub Actions. So we make a .github folder, which stores all of our GitHub files. We can have code owners, we can have pull request templates. We also have workflows. Workflows are actual pipeline objects. And I'm going to try and wrap this up in like 5 minutes so anyone can ask questions. And we have these two files. What are these files? What are they doing? Well, if we look at the name of them, we have a master CI/CD and a pull request. I'm just going to clean up these tabs. Let's first look at pull request. Now the syntax for this, you can Google on your own and you can figure it out. But if we look at it, it's pretty self-intuitive. We've got a name for our pipeline. It's going to run on pull requests into the master branch. And then we have some jobs. We have one job called lint and test web, and we have one that's called lint and test API. It's going to work, it's going to run in our working directory example Buffalo box. So example Buffalo box, because it's linting and testing web. And then lint and test API is going to run inside example API because we want to lint and test it in the API directly. Cool. And then all we're simply going to do is make build, make lint, make test. Make build utils, make lint, make test. Which simply is going to lint and test our application. That's pretty straightforward. We could theoretically do the same thing locally if we just, let's go to API, for example. We already built it. Let's just run make lint. Make build. I could do make build utils, which is going to simply build a Docker image that has a couple of fancy Go tools like GoLint and GoJUnit report. However, that's going to take a lot of time. So we're not going to do that because I have slow internet. But theoretically, that would build lint and test our application. And then we have master CI/CD. So this is going to run on push to master. So if we're doing and following trunk-based development, we only want to deploy when we push into our main revision. And it's going to run these two jobs, actually 3 jobs. Deploy presentation, which is going to simply build and push the static assets for our presentation application right here, which just simply runs the little presentation that I showed you right here. We also have deploy web and we also have deploy API. So deploy web and deploy presentation are very similar because they're both websites that we want to build and push assets. But we also have deploy API, which is a little different. So the fun thing about GitHub Actions is you can kind of import these modules from other places that will do things for you, kind of like packages and code. So I'm importing and using an AWS action made by AWS. I highly recommend only using actions made by the actual people that do whatever that tool is. Don't use some random action made by some Joe Schmo, unless you actually want to look at the code that they're using. So this is simply going to authenticate with the AWS CLI using a GitHub secret that I'm storing inside of my repo. So you can store secrets inside of settings, secrets, for example, AWS key, secret, and kubeconfig. Those are just secrets that you can create, with a name and a value. Pretty simple. And then you can just reference it by just doing secrets and then the name. And then similarly, we're going to build and push our Docker image. And then we're going to do this fancy Helm deploy. It's using .github actions Helm. What is that? Let's go here. We've got a Docker file and an action and an entry point. So let's look at the entry point first. What is this doing? It's taking a kubeconfig environment variable. It's putting it in a file, and then it's setting another environment variable called kubeconfig that points to that file. And then it just runs Helm with all of our arguments. So if we look here, we have env kubeconfig, which is taking our secret kubeconfig file, which is simply just plain text for a kubeconfig. We're going to put that in a file. We're going to create another environment variable. And TLDR, this is how we actually authenticate with Kubernetes. Then we're just going to run Helm upgrade, the literal command that I wrote that I was going to press enter like 10 minutes ago. We're just going to run that. And that's it. So this is a local action that I created that simply runs a Docker container. So that's how easy it is to make your own modules in GitHub Actions. It's just a container. You have your action.yaml, which is kind of your metadata. In this example, all I'm doing is running an image using a Docker file in the same path. And then that Docker file has an entry point that's doing some stuff in Bash. Cool. So if we wanted to see all of this go into play, we would create a pull request, and that would actually run our CI. So let's look at a couple of actions that we're running most recently. So, right when I started this presentation, I created that link. Let's test it. Boom. So remember before I said that I was going to push up something that had a link in the website to the repo? It's right there. Why? Because I had that CI/CD run when I merged into master. So if we look here, we can see build and push static assets to S3, build and push web static assets, build and push our actual Helm chart. So we kind of know how this works because you're simply just S3 copying. This one is what we kind of want to look at. So we have pushing our Docker image to ECR, which we would do locally, or we could do in CI/CD. Then we also have our Helm deploy, which is running our local GitHub action. If we look here, release has been upgraded, happy helming, and this is just basic output for doing the Helm upgrade. To specify more, we can get all resources in our Buffalo box namespace, which would have been upgraded. So I think I did a deploy like 50 minutes ago. Yeah, that's when I did the presentation upgrade because it's just going to run the whole CI. And then similarly on all PRs, we're going to run lint and test web and lint and test API. So it's going to build lint and test. Make lint, it's going to ESLint, make test, it's going to run jest. Lint and test API, it's going to do the same thing. It's going to build our image, it's going to lint it, and it's going to test it. So that was a mouthful. And the last thing, after all of this has been done, if we go to www.buffalobox.live or .com, we have our example that was running locally, but now at buffalobox.com. With Healthy coming directly from API buffalobox.com/health. Now that was a crap load of words that I just spat out in the past hour. And that's kind of why I kind of wanted to make a more in-depth doc with all of this that has getting started, Docker build, AWS, DNS, cops, and Kates that literally goes through all of the commands that you would have to run to do what I just did right now. Takes you through how to create a cert, how to build your image, a rough overview of Kubernetes with links to other documentation. And that's it. We only have a couple of minutes. I apologize. Do any of you guys have questions? All right. that's all I got. I really appreciate your time and going through this process with me. This was my first legit presentation I've probably ever had. So thank you for being my first audience. So yeah, if you guys have any questions, feel free to reach out to me. I guess on a final note, one more thing. If you're an SRE, none of this is new. There are other things that we would need to add to productionalize this environment, from monitoring, metric collection. Do we want to auto scale logs? Should we be using the default VPC? No. Should we add security groups? Maybe, if we want to have private facing APIs. What about databases? What if we use something like Terraform, because AWS console, bad. And that's it. You guys can find me on LinkedIn, GitHub. My personal information should also be on my LinkedIn profile. Feel free to send me a message if you just want to chat, or you have an example API, or you have a service that you want to actually do all of this with. Definitely, I can lend a hand if needed. So yeah, thanks for your time, guys.